Welcome to the St. John's Network. Today we're going to be heading into the Riken Center to take a closer look at what I personally find to be one of the coolest teams that we have here at St. John's, the Robotics team. The Robotics team takes place every Monday, Wednesday, and Friday in the Kelly Makerspace. After school, this 2,400 square foot lab is packed with students all working towards the same goal, to make a winning robot. So let's take a closer look at the Robotics team and get a little bit of a behind-the-scenes look at what goes into making the robot.
And then this behemoth here is friggin', you have probably about 10 coders, you have 15 people working on outreach to get funding, all this stuff. You have another like 10 people working on like mechanical parts of the robot. It's such a large operation that I've been mostly calling it design by committee.
If you were to say like Pioneer Robotics is a company, right? We split up into 3 divisions. We have our research, design, and build division. We have our programming division, and we have our outreach, our business division.
These 3 divisions each play a different role in the overall success of the team. And throughout the year, these 3 divisions must work together to produce a winning robot. So to kick things off, let's take a look at the design division, where the first conceptual idea of the robot begins.
So yeah, at the beginning of each season, the game reveal comes out. So what we participate in is FTC, which is First Tech Challenge. And at the beginning of every season, which happens early in the fall, they release a new game. So each year we compete in a new game. And then after the game is released, the entire team, which includes up to 30 plus members, we all sit inside of a room and we just design and take apart each element of the game. And we design components of our robot based around that.
And then we just go on the whiteboard, design, go through processes, see what works, what doesn't. Then after that, we split it into groups, and then we start prototyping. One group does one thing, another does another thing.
So we spend about a week in our design process, getting initial design into fruition before we start testing.
And even that is the end. Like, they test it, final design, during the competition. And it never works first try.
Nothing ever works the first time around. And so we're always like making fixes, making adjustments to the robot. And there are things that are out of our control that do go wrong. So we're always there for maintenance.
Like, I'm pretty sure Doctor is going to use this as an engineering example in his classes, but I was really dedicated to like a hanging design. That was very neat. It was very cool. I had to make so many custom parts for it. But I did not think far enough ahead to where a crucial part of it it would not work. And I got to that crucial part at the very last minute before competition. So no, you definitely do not know what you're gonna be making unless you have like foresight, like omnipotence or something.
All right, how many prototypes do you guys go through before you end up deciding the final product?
Yeah, we go through probably hundreds, if not, probably hundreds, tens if not hundreds of different prototypes. I know the chassis itself, I personally worked on that, so I can talk about that. That went through nearly 20 different prototypes because we first tried out with wood, and the aluminum, then the ACM, and then now the carbon fiber is finalized. But again, for different parts, like right now the intake has gone through like almost 7 or 8 different iterations. We've literally changed the entire design of our robot within like a 2-week span. So for our first qualifier, we used a robot that used a claw to grab the objects and the elements of the game this year. But now we're using a roller intake, which just like it's like how a Roomba works. It just sucks it into the robot. So we go through multiple iterations, not only just with parts themselves, but with entire robots. It takes a lot of time, but it definitely is worth it doing all of that.
I'm the lead of CAD, which is computer-aided design. That's 3D printing, laser cutting, and modeling, all that kind of thing. While most CADers in the team have a specific style they like or a specific department they like to do, for example, Rohan really loves his laser cutting. That's his dead set thing. Max likes his researching about 3D modeling. We have some people who are better at 3D printers, some people are better at lasering, all that stuff. I coordinate who gets the laser cutter when and what, who gets the 3D printers when and what. Time. It's interesting, but we have we're a little bit different from the rest of the group without actually being like a completely different thing. Like some the builders can CAD, but they're not that good at it, or they don't like specialize in it. So I don't know. It's very like informal and just like whoever's good will stand out.
We use the CAD software Fusion 360 to make CAD models and renders of our design. And after that, we prototype out of wood to see how everything fits together before we go and commit to materials like carbon fiber or aluminum. Yeah, so there are multiple facets to when it comes to creating items or objects on the robot. The side plates of our robot, they're made out of carbon fiber. We have a company out in Canada that we work with who mill the parts for us. We have a CAD room inside of the lab where we print out of polycarbonate for parts for the robot. We have a laser cutter, which we use to prototype. We have a CNC machine, which we're doing more research into and how to use that to make carbon fiber or aluminum parts for the robot in-house to save on costs. And again, it's a really, really cool space where we get to utilize these machines to make robot parts. So yeah.
Yeah. So I think the most important thing is the guts of the robot, just all the electrical pieces. Batteries, of course, are very important. Mechanism wheels, those are the fancy multi-wheels on the bottom that we have. And then it really varies for what you're going to do. For the most part, you're going to typically want a hook for every single year because there's some sort of hanging or balance component to the robot. And then typically you're going to want a belt chain system of some type for shooting or for this year, mostly picking up and dropping things. But it really varies depending on competition to competition.
But one big thing that we do after the robot is done is documentation. So a big part of FTC and the FIRST community is making sure that we're not just putting together a robot, but learning how it works and why it works and the science behind it. And so we document everything we do, from failing at making the first prototype of an intake to seeing how we adapted, how we learned, how we talked to other companies in the area, and how they helped us to finalize on a design. So documentation is a huge part of it. We sit down for almost a week just documenting everything that we've done throughout the year, reflecting on what we've done, our triumphs and our mistakes that we can work on for the next year. But yeah, documentation is probably the biggest thing that we do after the robot is finalized.
So in FTC, there's two kind of modes of programming. So first there's teleop, which is where the movements of the robot are entirely dictated by movements on a controller made by two drivers. So the programmer's responsibility is to program all these movements in and also to provide any sort of driver enhancements that make their job easier. And then the second part of the game is called autonomous, which is where all of the movements of the robot are dictated by a program. So that's what programmers spend most of their time on, and really what it comes down to is taking in sensor information from the robot and using that to be able to change the position of the robot and do mechanism actions in order to score points. So we mainly use Java with a software development kit that's provided by FTC. It allows us to easily interface with the various mechanisms that are on the robot. So we do all of our programming on just a laptop on Android Studio. But there are control hubs on the robot, which is basically the brain of the robot, and that's where the code goes, and that's where it runs on.
So it's required to work on the robot. They actually put in a few measures in place when teams started using the CPU on cameras to perform some computations. They actually banned certain cameras so that all code has to be fairly optimized, fairly straightforward in order for it to work efficiently on the robot.
And since the hardware is so limited, we really have to get creative with the sort of solutions that we come up with so that the robot is able to run fast enough to be able to do complex things on the field. So for example, we came up with the odometry system, which is a way of tracking the robot's location on the field because our robot currently doesn't have enough processing power to do some sort of odometry, localization based on the camera or something like that.
What type of things do you code the robot to do besides just the controller inputs for it?
So, a big part of it is the robot doing things by itself. So we spend a lot of time over the summer, while we're waiting for a robot to actually be built, trying to come up with ways for the robot to be able to move itself around by in its own way. And this is a very complex problem because there's a lot of things that can change around the match. So for example, like what is your robot expected to do if another robot moves in front of it, and how is it supposed to know that there's a robot in front of it, and how is it supposed to react to that? So we spend a lot of time trying to develop things that allow the robot to be adaptable and complex throughout the match, because it really ups our game when compared to other teams.
What type of sensors do you equip the robot with? Like camera sensors, pressure sensors?
So one of the main parts of the FTC game every year is a computer vision aspect. So basically, at the beginning of the match, something is randomized. Some like this year, for example, the team prop is placed in a random spot, and based on where it's placed, we have to figure out where it is and do something different based on that. So so we have to have a camera on the robot to be able to account for that. And we also use things like optical distance sensors and color sensors to provide information to the robot that allow for the drivers to have a simplified job. So for example, we have color sensors in our storage space for where the game elements go, so that the driver doesn't have to guess whether or not there are things inside of the robot, and it can know for sure whether or not there's something inside the robot and if it can leave or not.
Could you go over how the autonomous driving works? Like how...
Yeah, so basically there's something called an open loop control system, where the robot takes in data that it's getting from sensors, so like the odometry wheels that spin and measure where the robot is moving, and it uses that data to correct its path. So for example, if the robot is veering slightly off to the left when it's moving in a straight line, it'll be able to detect that and correct for it to account for the error that's sort of built up along the way.
Are there areas that the programming team is trying to like expand on, like create new solutions for others?
Yeah, so like one of the major things about the autonomous is that it's pretty much static. So like for most teams, you know, they have an autonomous and it runs with the other team members in the alliance, and it does so very well by itself, but the robots don't really have a way to figure out if there's other robots in their way, or if like there's something that they have to go around if it's not already programmed into the code. So one thing that we're really working on and trying to focus on this year is being able to figure out real time where other objects and robots are on the field, so that we can use some sort of pathfinding navigation algorithm to be able to go around those and avoid those obstacles.
So this year we actually implemented a pure pursuit algorithm, which is essentially, in the past we have used a public library called Roadrunner to hold the code for our odometry. But this year, instead of using Roadrunner, because that is a closed source, or that is a closed library, instead we created our own using pure pursuit, where the robot paths to a set of points while cutting off the corners to save the time in its path. So by implementing pure pursuit on our own, we are able to have more control over how the robot, like how the code is interacting with the robot, and then how the robot is moving on field. Through our programming, we are able to make consistent, reliable, and highly optimized autonomous routines from each of the 4 starting spots to maximize the points during that autonomous period.
Yeah, so we do have a budget. I don't know if I can disclose the information of the budget because I've not discussed that. But we are given a set budget. We raise most of our funds through our outreach division. So the outreach division, what they're really good at is raising money and funds for our team, and also spreading like the STEM around like the Worcester area and just around our community in general. And so every year we run the summer camp over the summer to raise money from that. We use the monies raised from that to fund robot parts. We have sponsorships with a bunch of different companies, Coughlin Companies being our biggest sponsor. They provide a decent amount of our funds that help contribute to the creation of the robot.
How do you get the money on that? Yeah, we just email companies and say like we're an FTC team and like we need some money. Like you can sponsor us and like your name could be at competitions. We just find like those type.
So it's like advertising.
Yeah.
How do we get kids on the team?
Yeah, basically.
It's a lot of word of mouth. You can see the rooms there, the room in there has a lot of kids in it. And then some of those kids will graduate, and when they graduate, we're going to have some openings for some new guys on the team, and some of the guys on the team will invite a friend who they know is interested in robotics. And we also put flyers in the school, and it's open to anybody who wants to try out. And we do tryouts in there in the spring usually, and then we do another one in the fall. We do one in the spring because we need to know who's on the team going into the summer, because we're active in the summer. And then if there's a slot or two available, if somebody comes to St. John's who didn't do robotics before and has crazy amounts of talent and who wasn't around for the spring tryout, then there's another shot for trying out in the fall.
How do you decide who makes the team and who doesn't?
Bribery. Whoever pays me the most, that's who's on the team. You can see there's no poor kids in there. Just kidding. We put them through a whole bunch of tests. There's an acuity test for basic math, spatial reasoning, and sequential reasoning. And we have everybody take that one. Once that's done, kids indicate what they think they want to do. There are several main kind of tasks that happen in there. You've got programming, you've got CADing, you've got building, and you've got outreach. And some kids know immediately, I want to do outreach, I want to go to other schools, I want to spread this thing, and they already know what they want. Most of the kids who apply don't really know what they want, and some of them even who have done robotics, and they're like, yeah, I've been on a robotics team, and I really want to do robotics, but they don't really know what part. And so they might indicate, yeah, I think I want to build, and so we'll set up a building area, and a couple of the kids from the team will watch them do some basic building challenges and some more advanced building challenges. And we see if that matches what they say about themselves. And then we match that also with the tests that we gave just to see if things are lining up. Sometimes we'll have a kid who proclaims himself to be a fantastic builder. You put a hex key in his hand, he doesn't even know how to turn it. It's like, maybe we ought to think of you for some other aspect of the team than building. So that's what we do. We look for consistencies. And it's a long process. The tryout process takes about a week. Not everybody tries out for everything, but a lot of kids will try out for programming and building and outreach and CADing because they're not really sure what they want to do. And we want to give them a good chance to have a fair hearing in whatever it is that they're trying, that they think they want to do.
All right, so for someone who comes in not knowing what they want to do, how do you kind of help them decide what group they best fit with?
Well, that's why we run the tests. Suppose they do all four things and they stink at 3 of them and they're really good at one. We'll say, okay, you are off the charts in programming, so I know you wanted to be a builder, but I think you're going to be a better programmer than a builder. And so through some sweet talk and all that sort of stuff, you let the applicant know what you've seen from an objective standpoint. In other words, somebody like me coaching the team, it's like, I've been getting kids to try out for this for 7 years now. You're not on the strongest end on building, but you're really good in programming, so why don't you try that for starters? If you really want to build, maybe next summer you do something at WPI that works on building, and then you can come back as a builder. But for now, it looks like that's where your skills are. And sometimes kids don't like to hear what we see, and sometimes they do, but we're just honest with them.
All right, and then is there anything you would like to say to anyone who's looking to join a team in the future?
Bring plenty of cash. Bring plenty of cash. Someone wanting to be on it needs to know that the commitment level is very high. We strive to be a world-class team. In other words, every year going to the World Championships is a goal. We don't make it every year, but it's a goal. It's hard to do. The only way you're going to do it is if you show up a lot and grind it out. And We have a club for kids who don't want to really grind it out and don't want to live, eat, sleep, and sweat robotics. Bowie over here lives, eats, drinks. Come on, Bowie, get in the camera. This guy is here like in resource periods, before school, after school, summer, you name it, Bowie's here. And, but you know, some kids don't. Club. And club, he runs the club. He's one of the guys, he's been running the club all year. And you get guys like this, and this is somebody who's gonna help us get to Worlds. You get some kids who might come in and they wanna put in an hour and a half twice a week. That ain't gonna get us there. The club is for kids who don't wanna bleed robotics, but they wanna dabble with it in a little bit, and so there's room for that here as well.
I think that's it.
All right.
That was really good. Thank you.
Danke schön.
How do you personally see being on this team impacting you in the future?
It might help me get into a few other colleges.
I think this will help me in the future in like college.
Well, big thing of it is colleges love to see that you've had experience.
I think it'll really help me with what I want to get into, like engineering.
If you want to go into like computer science and like that kind of stuff, like AI.
They love to see you have experience like directly and hands-on, building, designing.
It helps me think without using instructions.
It'll like give you like a background so you get excel in college.
And another thing is internships.
It'll also help you like get a job, like internships and all like that.
Being on the robotics team, winning worlds can look very good on your resume.
Like outreach goes out to several companies. Like 3 months ago, we went out to iRobot, which they made the vacuum things. The Roomba, yeah, they made the Roomba. We did a tour of their facility. They told us some stuff. And yeah, there's just tons of companies, tons of internship opportunities.
It helped me like work on like my team skills and like teamwork and stuff like that.
It helps me like have like experience in like a team environment.
You gain a lot of things from being on a team environment, you know, like teamwork, leadership, and like working with others is really important, especially in engineering where like you can make one mistake and it screws everything over. One, also it gives me some connections to look forward to in the future, right? Like I know someone here is gonna be some crazy programmer I can like call in the future. So it's just, yeah, it's a lot of personal skills you gain from it as well as actual like physical connections you can use in the future. Yeah.
What is your favorite thing about the team?
My favorite thing about the team? I mean, it's a little stale, but I think it's how good we are. Because we are consistently second best team in the state, I'd say. And
a lot of people like success.
yeah, and we've got to Worlds. Well, technically we've qualified for Worlds twice. And me being on here has made me so much better because I'm around people who are 10 times smarter than me. So yeah, that's great.
I like the people on the team, as everybody here has been so friendly and kind and open. And it's been such a wonderful experience. I could say that I'm like friends with everybody on the team and I like talk to everybody.
I like the people in the building.
Definitely the fact that it gives me a good space to collaborate with others. I'm able to work with others to solve whatever problems we may have. And there's a lot of problems that we have to solve.
I like the ability to like the chance to like be with friends after school and still do something productive.
Like I like the community, like all the friends you make, because like you're probably gonna make some lifelong friends.
Everyone's really friendly and it's like a welcoming environment. It feels like it's fun to go to robotics. Yeah.
What is your favorite part of being on the team?
Favorite part? So this was like my introduction into the school, I'm not gonna lie. So I did the SJLI event where I met a few people, but this is my friend group basically. This is how I got into everyone at the school. And I've been loving every single part of it. I've learned so much. We're making drums, I'm a drummer, and during competition that'll be a lot of fun. But I think the most fun part about this is just the interactions that you can get with everyone in there. They're good people.